Here we have an example of a limit question asking us to find the limit as x approaches infinity of this given equation. Anytime you're asked to find the limit as x approaches infinity or negative infinity, what we're really talking about always in these situations is the horizontal asymptote, or the long-term behavior of this graph. So to do that, I like to use, when possible, what's called sort of the leading behavior method. And this is the quickest way I know to find a horizontal asymptote. Whenever you just need to find the answer real quick, what you want to do is you want to find what's called the leading behavior on the top and the bottom of the graph. The leading behavior is better known as the highest power of x. So if I look at this equation right here, I can see that on the top, the highest power of x is x to the fourth. X to the fourth is going to dominate x to the third every single time as our x values get bigger and bigger. On the bottom, what we'll see is our dominant term is x cubed. Technically 12x cubed would be our full dominant term on the bottom. So when I look at this, I'm really just looking at a more simplified version of this problem, because those are the only pieces that really matter for how this graph is going to behave for very, very large values of x. Once I narrow it down to this, I go through what I call either top heavy, bottom heavy, or balanced. I would see where the highest power of x is located. In this situation, what we can see is the highest power of x is located only on the top of the fraction. And so I refer to this as a top-heavy situation. When the dominant term is only on the top of your equation, that's a top-heavy scenario. And so what this is really saying to us is, as x gets big, the top of this graph is headed up to infinity. And the bottom of this fraction, while it's getting big, it really is kind of like a 1. The top is going to win out in this battle every single time. And so whenever we have a top-heavy scenario, no matter how heavy or not heavy, it's always going to be headed up to infinity. So the answer to this problem is always infinity whenever we're in a top-heavy scenario. And so what that means, if they're asking us in terms of a horizontal asymptote, is we have no horizontal asymptote in this situation, because this graph isn't headed towards a singular value. It's just headed up forever, heading off to infinity. So the long-term behavior is the limit as x heads to infinity for this equation is headed to infinity. And the answer to whether or not there's a horizontal asymptote is no, there's not a horizontal asymptote.